Hi everyone, and welcome to the sixth in our series of webinars about building the HS2 West Midlands stations. I'm Rachel and I'm the Senior Community Engagement and Stakeholder Manager for Interchange Station and the Automated People Mover, which this session focuses on. As ever, we've got some really great speakers today who've been very involved in the design of the People Mover and will be working on taking the People Mover forward into construction. But before we get to that, there's a couple of housekeeping issues that I just want to cover. So before we start, I just want to share some technical information. We don't anticipate any technical issues during the event, but should you experience any connection issues, for instance, if your feed freezes, wait for about 10 seconds and it will most likely correct itself. If this doesn't happen, use the leave button to exit the event and rejoin using the event link. If it still doesn't fix the issues, don't worry, we will be uploading today's session to our YouTube channel, so you'll be able to rewatch it at a later date. And we'll email all attendees to let you know when the recording is available to view. Also, I did want to let you know, just to outline that we want to have a really friendly, informative event today. We really want to get lots of questions and have a really good discussion. But in all our interactions, we do ask that people are respectful towards our staff. If you've got specific issues where perhaps our construction works are affecting you and you need to have a direct conversation with somebody, please do get in touch with us via our help desk, which is available 24 hours a day, 7 days a week, and we'll be absolutely happy to help wherever we can. If you want to find out more about our statement on conducting respectful conversations, that statement's available on our website and the details are all there. So in terms of our conversation today, I'm going to start by telling you a bit about the HS2 project. And as ever with these webinars, I apologise to those who've joined us before for other parts of the series because we cover a bit of the same ground. But we did feel that the overview is important for anyone new to our webinar to set the scene for you. I'm then going to hand over to Nigel, our HS2 design lead for the interchange station and the APM. And I should say at this point that APM stands for Automated People Mover, and we'll probably shorten it all the way through the webinar, as Automated People Mover is a bit of a mouthful. And Nigel's going to explain what the APM is, what its purpose is for HS2 and interchange station. And we'll then hear from Chris, who's led on the design of the APM for our station design contractor, Arup. Chris will explain the design for the APM, how we've designed both the viaduct and the stops for the APM, and all the different factors that we had to consider while we've been designing. At the end of the session, our panel will take questions from the audience, so please do feel free to pop your questions into the comments area as we go through the presentation, and we'll deal with these in the Q&A session. We might not be able to answer all of the questions that you post in the chat today, but we'll do our best. And if we don't manage to answer your question, please do get in touch with our help desk after the webinar, and then we can follow up with you. So I'm now going to take you through a little bit about the HS2 project. So for anyone who has not been to one of our sessions before, or who's not all that familiar with HS2 and what it is and what it's for, I'm just going to give you a really quick overview. So what actually is HS2? HS2 will be the new high-speed backbone of our rail network connecting city centres of Birmingham, Manchester and London. We're building HS2 in 3 phases. The dark blue line shows phase 1 of the route, which is currently under construction and goes from London to the West Midlands. This is due for a phased opening between 2029 and 2033. Phase 2A is shown in purple on this map and will go from the West Midlands to Crewe. And the Phase 2A bill, which gives us the powers we need to build this section of the railway, has been given royal assent, and the opening date for this part of the route will be brought into line with the Phase 1 opening, and that will speed up connections to the north of England. The bill to provide us with the powers to build the western leg of Phase 2B, which goes to Manchester in the north, has been submitted to Parliament, and that new line will include intermediate stops at Old Oak Common in West London, near Birmingham Airport, Manchester Airport and Crewe. For the West Midlands, there's 2 stations planned: Interchange Station, which was in Solihull, and a new terminus station in Birmingham city centre called Curzon Street Station. The line will also integrate into the East and West Coast main lines, so HS2 trains can cross over to the existing network and serve towns and cities in the north. HS2 trains will stop at over 25 stations, serving around half the population and cutting journey times north to south. This huge undertaking will be Britain's first new intercity railway north of London in 100 years and is Europe's largest infrastructure project. What is HS2 actually for? So HS2 is designed to address three key problems facing the nation. Our railways are overcrowded and desperately need more capacity. Our economy is unbalanced with more focus needed in the Midlands and the North. Our climate is changing and a huge part of working towards the low carbon economy will involve decarbonising our transport network. HS2 will provide more capacity, cut carbon and deliver better connectivity. So in terms of more capacity, just to give you a bit more information about each of those areas, the demand for rail travel in the UK has more than doubled in the last 20 years. HS2 will add vital capacity to the existing rail network by taking long distance trains off the network, creating thousands of extra seats and space for more local commuter and freight services. HS2 will also be the UK's low carbon alternative for long distance travel. So it will reduce the need for car and plane journeys and play a vital role in delivering the government's ambitious goal of Britain becoming net zero carbon by 2050. HS2 is also the most important economic regeneration project in decades. It will act as a catalyst for growth and help level up the country, boosting growth in the Midlands and North and open up new employment and leisure opportunities for millions of people. So this webinar series focuses on our two West Midlands stations. There'll be 4 stations on phase 1 of the route. London Euston will be expanded and redeveloped to accommodate HS2 trains, and then there'll be a new station at Old Oak Common and 2 new stations in the West Midlands, as I've outlined previously. Interchange station's location is shown on the map here in the area circled in red. The station will be built on land bounded by the A452, the A45 and the M42 in Solihull. Interchange will be the first HS2 station outside of London and will have an automated people mover, which will cross the M42 motorway and connect the new station with the NEC, the National Exhibition Centre, Birmingham International and Birmingham Airport. And once the line leaves Interchange Station, it either branches off to the north and up to phase 2A or travels on a spur into Birmingham to Curzon Street, which will be a terminus station near Moore Street Station. So I'm now going to hand over to Nigel, who's going to give you a bit of an overview into what an APM actually is.
Thanks, Rachel. Hi, everyone. I'm Nigel, HS2's lead architect for the automated people mover and interchange station. My role is to oversee its design and ensure it aligns with HS2's design requirements and the HS2 vision. I'm going to explain what an automated people mover is and how it features Interchange Station. But firstly, I'm going to give a brief introduction to Interchange Station. So, Interchange Station will be a major gateway station for the West Midlands region and will connect passengers to city centres across the UK. When fully operational, passengers will be able to reach Manchester in just 37 minutes and London Euston in 38 minutes. There will be up to 5 trains per hour in each direction stopping at interchange. Interchange Station and the proposals from the Urban Growth Company for the development of the area surrounding the station will mean that this area will become a hub for economic growth. The station will be comprised of the concourse building and 2 island platforms, each 415 metres long, which will provide 4 platform sides that trains will stop at. The automated people mover connects to the station and will carry up to 2,100 passengers per hour in each direction. You can just see the linear feature that is the Interchange Station APM stop at the bottom left-hand side of this image. So, what is an automated people mover? Automated people movers consist of automated, electric-powered, driverless vehicles typically operated on steel or concrete guideways or viaducts. The appeal of people movers is their relative simplicity when compared to underground rail projects. The origin of people movers dates back to the late 1960s and early 70s, when they were first developed as part of mass transit systems, particularly in the USA, in response to growing congestion and pollution in city centres due to increased car usage. Now, over 50 international airports around the world now feature or have plans for people mover systems to transport passengers between terminals or connect other public transport systems to adjacent cities. Now, in the UK, you may be familiar with the people mover at Heathrow Terminal 5. This is an image of that. The Terminal 5 APM links 3 stations and runs in a tunnel around half a mile in length. The system uses a fleet of 10 vehicles which convey over 6,500 passengers per hour in each direction. A people mover that is due to open this year is the Luton Airport Dart. This is a 2-track mass passenger transit system carrying passengers the 2 kilometres between the Parkway station and Luton Airport. The operation of the system will be supervised remotely by an operations controller based in the Parkway station. The system will be capable of carrying 2,730 passengers per hour in each direction. A little bit more information on that one. The trains are propelled along by a traction cable mounted in the centre of the track. Each train consists of 4 cars closely coupled with open gangways to allow passengers to walk through the train. The trains are provided with wide doors to allow rapid boarding and alighting and are designed to take a peak load of 170 passengers. The journey time from the Parkway station platform to arriving at Central Terminal Station is just 3 minutes. So, moving on to the APM itself. What is the role of the APM at Interchange Station? The APM is designed to take passengers from Interchange Station in a seamless onward journey to Birmingham International Airport. Passengers will be able to alight from a train at Interchange and transfer to the APM directly from the station concourse and be at the airport stop in about 6 minutes without the need to transfer to buses or taxis. With services operating every 3 minutes, passengers can also alight at the other APM stops for the National Exhibition Centre and Birmingham International Station for onward travel to other stations on the wider rail network. The system will be capable of carrying 2,100 passengers per hour in each direction over a viaduct for the entire route. Just some dates to give you an indication of where we are. Planning approval was received in 2020, with construction due to commence in 2027 and passenger services due to start in 2029. So the final slide from me. Here we can see the route of the APM overlaid on the existing site. To the northwest is Birmingham Airport. So moving from west to east, we have Birmingham International Railway Station stop, then the NEC stop, and finally Interchange Station in the east. So that's it from me. I'm now going to hand over to Chris, who is going to cover more detail of the architectural and structural design principles of the APM.
Hi everyone, my name's Chris Jackson and I work for Arup. We are a firm of over 16,000 people globally, undertaking design engineering consultancy. For the past few years, I have been leading the APM design teams, developing the scheme design and planning submissions, with a team of over 100 specialists contributing at various points, and this has been based in our offices in Solihull. I'm going to talk through the design development of the APM, running through from the site context in where it sits, through the high-level design vision and targets we set ourselves, and then how this is applied to achieve the design that you may have seen in the planning submissions. As has been mentioned previously, please do add questions to the chat during the presentation, and we'll pick these up at the end. So before designing any structure, I think it's always very important to understand your site and the context into which you're going to place that structure. For the APM, this is a particularly challenging thing to do, as the site we're crossing has huge amounts of variability, and there isn't one land use or style from which to take inspiration. So from the east of the scheme, we have the brand new station that Nigel's described, that the system ties into. The route then passes through open countryside, that in time is likely to become developed, through the NEC site, which is a mixture of car parks, open green spaces, crossing a lake, and also with a wide different range of building sizes, scales and designs from various historic eras. And finally, the route heads to the airport, which again has a very different history range of architectural styles to consider. Added to this complex existing picture is the future. This is a highly dynamic site with many developments planned as part of various schemes in the area, in particular the UK Central scheme. And this will change many of those land uses from what they are now. So what the APM sees today, maybe not, or almost certainly won't be what it sees in the future. In light of that, and at this point, it's worth touching on something that we're not going to focus on in this session, but some viewers may be aware of. This presentation is going to focus on what's known as the base scheme, that being a development of the alignment for the people mover put forward as part of the HS2 Act. However, we have also been working on an option with the Urban Growth Company to realign a section of the route in order to future-proof plans for redevelopment of Birmingham International Station, and also by doing so maximise the opportunities for commercial development around that station. At the moment, we are working and progressing these two schemes in parallel, and we expect there will be a decision point in the summer this year about which option is taken forward to construction. With UGC currently working with its partners to identify and secure the additional funding required for the realignment so it can fully enable commercial development opportunities for the future and the future transformation of Birmingham Birmingham International Station. So moving into the design, I'm going to start with the very high level principles. So within this complex and variable site, how did we establish what our principles were? Our starting point was HS2's route-wide principles, that of people, place, and time. This is aimed at making sure that the HS2 system is designed for the people that come into contact with it, however that may be, and that's through accessible design for users and design quality for those who see the system. Place refers to creating designs that give a real sense of the place they're in, that create places for the future and respond to the existing narratives that already exist. Time we refer to is designing long-lasting, durable structures that are high quality now and into the future, so will stand the test of time. So applying this to the APM, the focus on people has two sides. Firstly, the user of the system. To address this, we have designed with the aim of creating simple, intuitive passenger journeys through the stops that work for all our users, and that's regardless of accessibility issues they may have as individuals. And as part of this, we apply consistent design principles across the stop, but in order to respond to the place aspect as well, we create ability for elements of the stop to be tailored to their location. For the viaduct structure, the response to people is largely the many thousands of people a day who will see this structure from various angles, be they at the NEC, be they users of the M42 or West Coast Main Line or the stations. To respond to this element, we have focused our efforts on making the structure both visually light and having a low footprint on the ground, so as not to make the ground underneath the structure unusable. In responding to the time element, we've made the structures durable and able to be refined in the future, and this includes opportunities for technological changes that may come, in particular in what the APM system is. We are aware that many technologies are changing, and the system we build on day one may in the life of the structure be updated in many ways. Our overriding approach to the design challenge was to create a design language across the whole route, with the viaduct forming a consistent elevated ribbon that is visually the same wherever you are along the APM, with the stops combining common features that give it a very much an HS2 identity as part of the HS2 system, while still allowing a level of customization to suit the challenges of each location and future developments that may occur within them. So from the high-level principles, we derived some more detailed considerations and aspirations. Firstly, we wanted the APM to respond to its site. We needed and wanted the engineering to be efficient to give best value, whilst also achieving the structural requirements. Due to the challenges of the site, we wanted to make sure that as far as possible, large elements could be fabricated either off-site or in large modules and lifted into place to minimize disruption to the many land users. We needed our spans of the viaduct to be flexible because the obstacles we cross are not all uniform. We wanted and needed the structure to be durable, so it will last a long time and it will provide value by being usable for as far as we can possibly see ahead. The design had to respond to the functional requirements of what the APM system was, and I'll show a slide on that in a moment. And then the final two are key as well. The design had to be accessible. HS2 is trying to be accessible to all users, and the APM is no different in that regard. And finally, we wanted the design to add quality to the area, so to be an aesthetic design that visually people would enjoy, and not just the bare bones functional design that can sometimes occur. So with these high principles set, I'm now going to talk through each of the key elements we designed, starting with the viaduct. So in the design of the viaduct, the starting point was to understand what the viaduct was carrying. The APM system is unique within the HS2 project, and the viaduct structure was therefore developed from first principles to meet the specific requirements of it. The route includes areas where we have single track, areas where we have two tracks but on one sort of bridge deck, and areas where we have two separate structures running in parallel. And you can see this on the plans at the top on this slide. Combined with this layout, the viaduct also needs to be capable of crossing a range of obstacles, which include the M42 motorway and West Coast Mainline Railway, with spans of up to 70 meters, plus multiple car parks, green fields, lakes, many local roads of different scales of magnitudes, and also even a building at the NEC. So how did we attack this problem? So the thought process for the design of the viaduct was firstly to consider the key functions it was carrying out, its sort of functional requirements. And the main operational requirement is to carry a track for the APM system and an adjacent access walkway. And this is shown on the top left image. If we just place these on a standard bridge deck, where the beams are underneath a deck slab, combined with the height of that walkway and the depth of the track system, we would end up with a very visually deep structure, which would be heavy in the landscape and would be very difficult to blend in aesthetically across the site. To get around this, we took the design decision, and this is seen, you can see this on the bottom left image. To get around this, we placed the track between the beams, so lifted the beams up, allowing the overall depth to be reduced, and in effect making the depth of the walkway and track and the depth of the structure overlap rather than be on top of each other. This reduced the depth, and from that we then did various pieces of detailing and design to enhance the appearance, such as we inclined the beams in slightly. So rather than a vertical face, you have an angled face, and we worked very hard with the fin type stiffener elements, which are a structural requirement for the beam and to support the walkway, to shape these and come up with a design that provided the structural requirements, but also was shaped and considered and enhanced the aesthetic overall. Following that, the viaduct columns were studied in detail with a range of shapes and options considered. And it was decided that the best approach was to keep these as simple as possible, with a shaped column which has a consistent detail at the top of the column, and then a uniform vertical shaft. The logic being there that the shaped column, the shaped piece is kept the same, and the vertical constant shaft is varied to suit the various heights of the system across the route. And then in terms of materials, we used a contrasting material of concrete compared to the steel of the deck, to really try and enhance and bring out the deck ribbon concept we described earlier. After these thoughts, the depth of the beam that suited the track and walkway level naturally lent itself to spans of around 40 meters, giving a balance of structural efficiency and the design we come up with. And this was then tested on the route and found to be sufficient for the majority of obstacles to be crossed without being excessive or wasteful. So following that design process, this slide simply shows a couple of visuals of the viaduct form. It shows the standard deck and span proportions on the left, and a bit of a detail of the pier head on the right. And the entire line of the APM route uses a structural form derived from these studies. A key part of the viaduct design is also the materials. In choosing materials to build a viaduct, it is essential to consider both strength, durability, and appearance, and how it is going to be built. For the deck of the APM, the eventual choice of material was to use weathering steel. This is a material provides an opportunity to fabricate large modules at ground level prior to lifting into position, essential when you're working in the range of sites with multiple activities going on the APM passes through. These sites mean that access is naturally restricted and difficult for construction. The material itself is not painted. It develops what's called a protective patina over time, where it moves from quite an orange color initially to a much deeper uniform brown color. This patina also acts to protect the structure from future corrosion, therefore no painting is required. The columns themselves are reinforced concrete, which is strong, durable, and also a very good material when you have vehicles moving around, as it can withstand impacts from vehicles at ground level, and it also provides the visual contrast with the deck. So I've discussed the viaduct and the standard spans, but I also mentioned that there are locations where spans in the order of 70 meters are needed. That's nearly double the standard span and quite a structural engineering challenge. These locations are the West Coast Main Line and the M42 motorway, and these are shown with the yellow orangey arrows on this plan. So to deal with these locations, we were keen to keep the same visual line of the viaduct running through and not change our structural form, but we did need more structure and capacity to span the larger distance. To achieve this, the beam is haunched, i.e. it is deepened at the piers, and there's also actually a slightly deeper beam in the mid-span, and you can see this on the massing diagram and the two elevations of this slide. This gives the additional capacity required whilst continuing the concept of the viaduct design and not breaking the visual line across the route that we were trying to achieve. So combining all these features, this slide shows the visualizations of the viaduct across the route. And I think it does show the successful combination of the engineering and the architecture into a single structure. Particularly the top image, I think, shows the slender deck and the benefits of the studies to make it thinner than would normally be the case. And the pier spacings do prevent it impinging in the landscape too much. So next, I'm going to move on to describe the design of the buildings across the APM route and site. So I'm going to start with the stops. The design of the stops aims to realize the design vision by applying principles of modernity. We're trying to use the best of current engineering and transport technology within the stops. Minimal, we're trying to create simple, clear and calm environments for passengers and those that can come into contact with the system. And to be functional. The system needs to be reliable for people to want to use it, and needs to be easy to maintain, and these combine to ensure it provides a functional service to the users for the future. As previously mentioned, there are two main categories. Sorry, the slide's slightly out of sync. So what are the technical drivers for the stops? Firstly, the alignment, the location, orientation and high-level layout of the stops are all determined by the alignment of the route, which is in turn has been determined by the site and has been studied over the preparation of the hybrid bill and more recent works. The stops are then required to provide weather protection to users to ensure comfort when using, and although they are not internal spaces, they do need to be a comfortable place to stand and wait for the APM, albeit that the time you're waiting is only a few minutes. With the APM largely at height, vertical circulation is a key component of each stop, with requirements for both efficient transfer of passengers between levels, but also providing vertical transportation that accommodates all users' needs and is readily available when wanted. APM systems themselves require a range of plant, mechanical and electrical equipment in order to operate safely and efficiently. And as a self-contained system, this all needs to be contained within the stops themselves, with all the services that can connect the stops for communication, power, etc., carried between the stops on the viaduct. And finally, the stops need to be appropriate for use in all weather conditions, which, as we know, can be a bit variable in the UK. So I do apologize, I think the slide got slightly out of sync. Within the APM system, there are three main categories of buildings. There's the terminus stops at Interchange Station and Birmingham Airport that have single-sided platforms, and these are required to house the majority of the equipment to drive the system. The intermediate stops at the NEC and Birmingham International Railway Station have island platforms, that being between two tracks, with much lower levels of equipment provided as they are within the sort of intermediate and the system. And then finally, there's a maintenance facility building that is not publicly accessible and provides a base for maintenance, cleaning and repair of the APM vehicles, and that is located adjacent to the M42. So looking at the differences between the two main categories of stops, the terminus versus the intermediates, this slide shows a terminus stop on the left, in this case interchange station, an intermediate stop on the right being the NEC. And these exploded diagrams sort of show the layout. The terminus stops are conceived as multi-storey independent buildings with the levels under the platform to house plant and motor equipment. The single-sided platform is then effectively on the roof of this plant area. At the interchange station stop, the building is recessed into the landscape, giving level access from the platform onto the station concourse and onwards to HS2 train services. At Birmingham Airport, escalators are used to bring passengers to ground level. For the intermediate stops, the approach is very different. The system layout requires an island platform with APM vehicles on each side. To achieve this, the APM viaduct continues through the stop on each side of the platform, with the platform structure then spanning between the two decks. In effect, the stop is hanging off the viaduct. Lift cores and escape cores provide vertical elements for access, with a single-storey plant building at ground level. Escalators are provided up to the island platform from ground level at the NEC and to a mid-level mezzanine at Birmingham International Railway Station. So I'm just going to look at the visuals of these two categories of stop in turn. And the two terminus stops are shown on this slide. On the left is the interchange station stop, showing the level access to the station and very much an understated design. The aim here was to very much blend into the landscape and allow the new interchange station to be the main structural event. On the right is the airport stop. The level of the viaduct crossing the airport access roads dictates that a much taller building is required, with escalators and lifts to provide access to the platform level. The building under the platform houses a wide range of plant and equipment required to operate the system, over 2 stories. In both stops, you can see the use of a coloured linear element within the canopies, integrated whilst providing a clear visual clue to the passenger journey. For the airport stop, this feature also integrates and wraps around the lift shafts, which are located to ensure that passengers requiring their use can easily locate these and do not have to deviate from their natural route of travel in order to do so. Moving on to the intermediate stops, the difference in approach is immediately apparent on these visuals. The viaduct visual element continues through the stop, with platforms and access to the island platform between the decks. Again, the use of the coloured element in the canopy denotes the route through the stop for users, with the lift cores located to be immediately apparent to users on entry to the stop. The left images are the NEC, where the system is at its highest point for the whole route, with the escalators passing between the 2 separate lift cores to provide the required length for the vertical height. On the right-hand side is the Birmingham International Rail Station stop, which rather than having ground level access, the escalators and lifts meet on a mezzanine level with a link bridge directly into the existing International Rail Station concourse. This separates passengers and traffic at ground level. So I mentioned earlier that we'd also try to apply common elements throughout the stops. So I thought it was worth touching on what we mean by this. So within each stop, the design aims to provide consistency of passenger experience. This means that features that you see from within the stop, such as canopies, the lifts, the escalators, the platform edge barriers, signage, etc., are repeated elements that are used exactly the same way in every stop. In addition, we have the coloured roof feature, which donates the primary passenger route through the stop and is intended to aid intuitive and simple wayfinding. This is also enhanced by ensuring that there are clear open sight lines whereby the exit route or your route to the platform is clearly visible from entering or leaving the stop. The smaller details such as signage, departure boards, etc. are also consistently applied across the route. This approach means that internally, all the stops have the same internal design language, which gives consistency to the user across the route. So I'm now going to move on to the maintenance facility building. The maintenance facility is by its very nature a very different structure. It is located partway along the APM route adjacent to the M42 motorway. It is a private building and therefore public interaction is largely from a distance from the M42 motorway or from the future developments that may take place around the site, or indeed from an APM vehicle passing by on the viaduct. Unusually for a maintenance building for rolling stock, the activities largely take place at an elevated level. This is a direct result of an early design decision to move away from the hybrid build layout, which is on the left of this slide, where maintenance took place at the end of a long spur off the main route to the south of the interchange station. By removing this spur, both the physical and carbon footprint and the environmental impacts of the scheme were significantly reduced, and more land was left available for further development opportunities. So onto the building itself. With the location decided, the design approach became to define the operational space requirements to carry out its maintenance function and to package these into a efficient building structure. Once the core operational shapes and areas were determined, the form of the building was developed. The location and height of the structure meant by necessity it would be a large building. Combined with most views being from a distance, it was decided that the best approach was to use large, simple shapes and simple coloured materials to create a strong visual form, devoid of fussy detail. And this form was derived from industrial buildings in the region to give context. So this slide shows visuals of the structure from a number of angles. The top two are each side of the building. The one on the left being from the adjacent fields and site, and the one on the right being from the M42 as you come off the southbound off-slip. And you can see the viaduct passing through as well. The bottom image is the wider context and is taken from the NEC exit road bridge that crosses over the motorway. This shows how the building presents against a congested backdrop of infrastructure and structures, and why there was this need for such bold shapes and form to be distinctive in the landscape. So thank you for your time. I hope you've enjoyed hearing about the design process, and we're now happy to take any questions. So please do continue to add these into the chat.
Thank you, Nigel, and thank you, Chris, for that really fascinating insight into the world of automated people movers. We're going to now move on to our question and answer session, and this slide is just a quick reminder on how to post your questions in the chat, which you can access at the top right of your screen. We have had a few questions as we've been going along, so I think people have been finding that place, which is brilliant. We'll try and get through as many questions as we can in the remaining time, but just a reminder that if we don't answer your question and you would like an answer, please do get in touch with our help desk and we'll have details of that at the end. So before we start responding to everybody's questions, I just want to thank you all for joining us today. I've really enjoyed the session, and we hope it's given you a bit more of an insight into some of the work we're undertaking and why we're doing it. On this slide, we have actually included a QR code which links to an article that Chris wrote a little while ago about the APM. It's got quite a lot of more information in there, so if you'd like to do some further reading later on, please scan that code. We're giving everybody homework today. So I always do this, I think, but I'm just going to start off by answering a question myself, because that is the privilege of being the chair and sitting and listening to everybody. So one of the first questions that we got through was about are there possibilities of changes that would assist the introduction of the Williams, I think it's SHAPS IRP, the Integrated Rail Plan. So at the moment, we're not anticipating any changes to Interchange Station or the APM as a result of that plan. Obviously, there's lots of detail for the government to work through yet, and we await that. But in answer to that question, I think at the moment we don't anticipate that. Also, I was going to just start with Nigel. I think there's been quite a few design related questions, so Chris is going to be peppered with questions in a moment, but just quickly, Nigel, if we start off with you and ask what do you think is going to be one of the most challenging aspects of constructing the APM?
Hi everyone again. Yeah, thanks Rachel. I think really it is the challenge of working at an elevated level. Obviously Chris has talked through some of the change of land use across the site, going across a mainline railway. We're going across the M42 motorway. That in itself is a huge challenge. We've got to put foundations into the lake that is on the route. So there's a myriad of challenges, all requiring multiple and varied engineering solutions. It's probably fair to say that anything to do with spanning an existing railway is probably the biggest challenge in terms of the logistics of it. So I think that's probably the answer to those.
Thanks very much, Nigel. And Chris, how does an APM throughput compare to underground, Docklands or bus shuttle?
So an APM system is generally not intended to provide the level of user, sort of number of users that say a tube train would. It's noticeably lower, and one of the reasons for selecting such a system here is because the modelling and demand modelling suggests that such a system would be, to put a tube type system on would be very wasteful in terms of cost and benefits. In terms of bus shuttles, it's probably higher than that. So it sort of sits in the middle. It's a little bit less than a DLR. It's a lot less than a tube. It's more than a bus shuttle, but it's very much chosen and tailored to respond to the anticipated demand that is in this area and the number of users we expect to have, including sensitivity studies and allowances if things don't turn out quite as we would expect. Predicting passenger numbers is always a slightly tricky exercise. There's robustness in there.
Absolutely. Thanks, Chris. And can you inform us about your approach as a designer to the existing utilities and interfacing with the existing facilities like the airport, Birmingham International Station, all the many things that are on that site?
Yep. So I'll take them in sort of as two separate things. Utilities, and anyone who's worked in civil engineering will know that a site like this is just riddled with utilities end to end. There's all sorts of things: cables, BT, power, gas mains, you name it. Somewhere on the APM route, we probably have each utility. The approach has been to, as far as possible, establish where they are, design to avoid impacts where we can, and then work with the utility owner and providers to arrange for diversions where we can't. So it's been a bit of an iterative process. We've worked with all the various utility stakeholders and the landowners, because this site, particularly around places like the NEC, has a lot of privately owned, so not the public utilities you might expect. In terms of working with so the airport or the NEC, we throughout our design process, we've had an extensive stakeholder engagement process where we have met with the various owners and operators of those sites, and we've discussed their needs, their requirements, concerns around construction, particularly, it was a common theme, but also concerns about what the design was, and we've worked with them. We've had many meetings over a period of time as the design is involved, and we've very much taken them on the journey from the start. So the intention being that when the final designs came out, they were on board and they were happy with what was produced. So a very collaborative process over quite a long period of time to take all the various site owners on the journey and make sure they understand what we're doing, that we address their concerns because they are very valid, and that they are implemented in the design.
Thanks, Chris. Yeah, I think the utilities is something that I hadn't realised how complicated that was going to be, and it is extremely complicated. And I think as well, it's worth it. We feel like we've come quite far with the APM in terms of design and stakeholder engagement, but there's a huge amount still to be done, and we will be kind of continuing to try and take everybody impacted on that journey with us. Next question that we have got is, will you consider designing place or space on the viaduct for the possible future expansion?
So I would say we already have. The viaduct itself is designed and envelopes all the various different APM systems types both types and manufacturer systems that we currently are aware of, with a certain degree of future proofing in there as well. So the viaduct, if in 20, 30 years time it's decided that a different system is appropriate because of changes in the area, then the viaduct, as far as you possibly can predict the future, is future proof to take that. So we have the challenge in doing that is to not provide for every possible eventuality and make a structure that is significantly more expensive or intensive on materials than it should be. But we have very much tried to make sure that we're not designing it down to one narrow route that cannot be changed in the future. So there is flexibility built in there already, as far as is reasonable. Okay.
Brilliant, thank you. And do we know how many vehicles will be in operation at any time? And if it's more than one, is that a problem on the single track sections?
So the system is designed for 4 vehicles to operate in a synchronized pattern on the system at any one time. So that's the general assumption, and that's what it's designed for. And that determined where we have the single versus 2 track sections of route. So those vehicles do operate in a synchronized way. As they're automated without drivers, that's, I'm not going to say it's simple because I think that would upset so particularly signaling design teams. It is complicated to do, but to run those in synchronization is perfectly technically feasible and is done on systems all over the world. So because they're synchronized and automated, it's then possible to have single track sections and passing loop sections. And that's where the layout of the 2 versus single tracks we had on the slide earlier comes from, is understanding that. So it's 4 vehicles, and we don't anticipate it's a major issue for operation.
Brilliant, thank you. And just another one, do the people movers park in the main? You might not know this is quite a level of detail, but just I'm trying you out. Do the people movers park in the maintenance shed overnight to be repaired, or are they lifted off the operational tracks? That's quite an interesting one. Like, do they sort of sit there when it's not in use, just on the track, or what happens?
So so the operations, so it depends on the level of maintenance. For normal routine day in, day out maintenance, cleaning, small part replacement, the maintenance facility, two of the vehicles are housed in there at any one time, and the majority of those operations would happen overnight. So they're taken off the route, parked in the maintenance facility, and then the maintenance happens there. That then means that 2 vehicles are parked within the stops. For the short periods, the whole system is not operational. In terms of major overhaul activities, which are very infrequent in the order of years, the vehicle would be removed from the route and taken away by road on a lorry to be done normally at the manufacturer's own facilities. So for major overhauls, that will be done away from the system, but for all routine maintenance, it's intended to be done in the maintenance facility, with 2 vehicles in there and 2 vehicles parked on the within the stops, sort of overnight stabling.
Brilliant, thank you, Chris. And a sort of connected question, do we know what hours the vehicles will be on the track and operational? If we set that, I suppose it's in line with when HS2 trains are operational.
Yeah, so within the hybrid bill, there were some minimum hours to operate. I must admit, off the top of my head, I can't quite recall them, but the final operating hours have not been set, but there is a minimum requirement there, and the intention is very much that it will be operating when HS2 trains are operating as a bare minimum, but but beyond that, it's decisions to be made yet.
Yeah, I think it's worth saying again, we are at a point in the journey where we've designed it and we know sort of what it will look like, but we've got to appoint our sort of contractors to actually build it, and then also for the systems, and then there's lots of discussions about kind of ownership and how it will run and that kind of thing, which again we'll be speaking to stakeholders about. So probably another one for you, Chris, I'm sorry. you're just getting bombarded. But what will the station canopies be made from?
So they are, the canopies themselves are a steel frame structurally, but the cladding material at this moment is envisioned to be sort of a pressed metal panel with insulation in, and sound insulation in it, so you don't get that tin roof drum effect you might get. But simple aluminium type cladding materials are currently proposed. There will be further study on that during the detailed design though to confirm the exact choice. But that's the sort of intent. But we are very aware of issues such that you can get with those sorts of canopies, such as noise from rain, and there are measures included within them to make sure that doesn't become a problem, such as the insulation I touched on.
Thank you. And Nigel, when does the APM have to be completed and operational? And could you give a little overview, just a high-level overview of the timelines for the procurement phase? You're on mute, Nigel. Can't do a webinar without that.
Sorry, yeah. That's a good point. Yeah, in terms of operational, I mentioned it in the presentation. So at the moment, we're looking at December. Well, it's towards the end of 2029 in terms of operation. I think in terms of contract award, that is some way off. We're talking potentially 2 or 3 years. So there's not going to be an immediate construction activity on the site. We're some years off that, as is the case with the HS2 station itself. We're certainly whilst there is work going on at the site at the moment in terms of quite a significant amount of enabling works, and that's earth moving works in association with the station, there's nothing directly happening with the APM at the moment.
Thanks, Nigel. And I think it's probably also worth saying, if anybody is interested in contract opportunities or supply chain opportunities, we've got a whole host of information on our website that tells you what contracts are out and and gives you lots of information about supply chain events and things as well. So if that is something you're interested in, please have a look. We just had one other question. So will you design console? I'm not sure if I'm interpreting this question quite right, so I'm going to read it as it's written and then Chris can answer it as he understands it. So will you design console to the outside of the viaduct for the catenary poles, or the catenary poles are going to be placed on the viaduct?
So I'm going to take the question as meaning connect to the outside of the viaduct. But there are no overhead wires or catenary poles planned as part of the APM. So the system, the APM systems are normally powered from either a cable pull type system. So there's actually a mechanical cable pulls the train along, and that's within the track. Or if there's a motor on the vehicle, power is collected from a rail alongside the track. So there's no overhead wires proposed, and power would come within the track system to the vehicles itself. Being a short system, the benefits of the high voltage overhead lines are not there, and a smaller DC type system is much more appropriate. And that's common across APMs globally. It's a commonly used system. It's not something we've pushed or innovated. It's a standard, well-tried solution.
Thanks, Chris. And we have one question. How much freedom do you have to move away from the 2017 Hybrid Act in the route?
So to go outside of the rules of the Act, we have none. But that said, the Act does include what's called a limit of deviation. So it has a route for the APM proposed, and it has a boundary within which you can realign and change that route. So the realignment we've looked at with UGC and the space scheme we presented today are within that boundary. We have tweaked and changed the alignment in places to optimize and get the best solution, but it's all has to be within the rules of the Hybrid Bill Act. How far that means you can move depends on how the act was written at the time. So in some places, it might be a very narrow corridor that you have to go through because there were restrictions or reasons why. And in some places, it can be quite wide if there was no particular issue that prevented you from doing so. So for parts of our APM route, the corridor was 20, 30 meters wide. In parts of our route, it's over 100 meters wide. And we were, as long as we stayed within those boundaries, we were free to change the alignment if we thought it was a better design than the one that was on the table.
Thanks, Chris. I think it's also worth saying that we have the limits of deviation, but we are also limited by the impacts of what we do within the hybrid bill. So the environmental statement that went with the hybrid bill set certain environmental minimum requirements that we also have to stay within. So we can't change something and have a worse impact without looking at how we then mitigate that impact. So we are quite set in what we need to do, but there's sort of room for manoeuvre to try and improve things if we can at all. So the next question I have got is for Nigel. So Nigel, has any consideration been taken into account about how the colour station design vision will be communicated? So I think the sort of colours for each of the stops, so it's not confused with the line of route rather than station. So for example, if you're travelling from London, you might have used TfL to reach Euston on the Northern Line, which is black, and that's how TfL map the routes with colours. So will people face a colour of a station, but will people then get to the APM and see a line, I guess, and be confused about the colour?
Okay, thanks, Rachel. Yeah, this is an interesting one. I think it is fair to say that there's a very high level design expectation for everything we do on HS2, and the APM is no different. And so, for example, at the moment, we're looking in a lot of detail at customer signage, and there will be some, as it were, what you might call market testing of that. So there will be designs developed for the representation of any mapping or any color schemes in relation to the APM. And I don't think that's on the table at the moment, but without question it will be. So I don't think there's any chance that we'll end up with a system that is potentially confusing. As I say, I think all due diligence is always anticipated to be taken in anything that is very sensitive, and certainly color aligns with the HS2 vision. So it won't happen by chance, and it will be a very measured and calculated and sophisticated solution. So I don't see that being an issue. I was also going to pick up the other query with regards to the APM maintenance building. Rachel, did you want to just run through that question, or just read that question out? Or I can track through and find it.
I can ask that. So why does the maintenance building need to have a bold design? Surely you want it to blend into the background and not be near the motorway, so it's not distracting.
Yeah, I thought I'd answer this question at the same time because I think it aligns with my response to the previous question. So everything on HS2 and the APM is the expectation to a very high level of design. With regards to the APM, of course, it is quite a significant structure across the landscape. And I think, as Chris has articulated very clearly, it's a very elegant solution, albeit there are large elements to it. So I don't think it's unreasonable that the maintenance building that could be a very simple functional response is actually given a degree of what you might call enhancement. We are looking for high quality solutions. So with regards to it potentially being distracting, I think in the sense that you've got a large bridge structure over the M42 in particular there, I wouldn't necessarily agree that that would be the case. I think obviously its location adjacent to the motorway it's not been singled out as particularly being located there. I think it's just a result of other considerations along the whole route and some of the technical or geological issues, shall we say.
Thanks, Nigel. I think we're just going to go to the final 2 questions. So we've had one about who will operate, manage, maintain the APM and the stations, which I will just answer. So in terms of operation of the APM, there are lots of ongoing discussions, so that's not completely decided yet. There'll be we'll construct it, and then in the run up to operation, there'll be lots of conversations about who will run and operate and maintain different elements of the scheme. So just for a final question for Chris before we let him go and have a cup of tea and get his breath back. Will the vehicles be steel wheel on steel rail or rubber tyre on concrete guideway?
So the short answer is to be decided, and that sounds non-committal. But the reason for that is that we, and I sort of touched on it with the viaduct design earlier, we're very keen to make this a structure that could deal with a wide range of APM system technologies, both for now and for the future. And therefore, or also just to give background, APM systems come as almost a package. So you go to a company that makes them, and they do the track, the trains, as a very large, complicated product. So the viaduct is designed to be able to take either a steel on steel type solution or a rubber tired solution, depending on what the market wants to bring. And that is one of the sort of, to my mind, one of the very good things in design is that gives flexibility both now and in the future for technology changes. So.
Brilliant, thank you very much. I think that's what we've got time for today. So thank you ever so much to our panel, Chris and Nigel, for your presentations and also for answering all those questions. If anybody does have any questions, we didn't have time to answer your question and you'd still like it to be answered, please do contact our help desk on 08081 434 434 by Minicom on 0801 456 472 or by email to hs2inquiries@hs2.org.uk, or you can visit our website at www.hs2.org.uk, and you can also obviously scan that QR code. There'll be a recording of this, so if you didn't get a chance to scan it before, you can do that again in the recording and people will be emailed with that information. So but yeah, if we haven't answered the question or you've come up with one later on, please do get in touch. And also feedback is really important to us. We do want to learn and improve all these sessions. So if you've got any feedback about the session, if you thought it was worthwhile or you've got ways that we could improve in the future, please do get in touch and fill out our survey and let us know what you thought. That should be emailed out to you. And if there are any future topics that you'd like to hear more about, again, please do let us know. And for more information about the HS2 project, you can, as I said, you can have a look at our website. We've also got local community websites which host lots of information about our stations, and this can be accessed through the In Your Area section of the website. You can stay in touch with our progress, and also we do now have an interactive map, so you can have a look at the bits of live construction that are going on and find out more about what's happening in your area. So please do check that all out on our website and stay in touch with us via social media. So finally, just want to say thank you again to our panel. Thank you to everybody for joining us today and hope you have a brilliant rest of the day. Thanks very much and goodbye.